All right, hello, calculus kids. Don't be freaked out at the screen right now. It's going to be okay. So first of all, if you got your 7 tests done, that is awesome. Congratulations. Just so you know, there's a couple of you who didn't do your second attempt at the test, and so you do have 2 attempts at the Chapter 7 test. So I reopened that up for today. So if you wanted to do your second attempt for your test, you could do that today. And you can look over and see what you did wrong to improve and learn from your mistakes. Anyway, okay, so what is on the screen? Why is this Lahapitals? I don't even know if that's how you pronounce the guy's name. Up on the screen. So Lahapitals rule is something that is in Calc 1. It may or may not be on the AP exam. There will be 1 or 2 questions on the final exam on Lahapitals rule. So what is it? So Lahapitals rule is another way to find the limit. So why didn't we learn this when we did the limits? Because his rule says you have to use the derivative. Well, guess what? We didn't learn derivatives yet because you have to know limits to do derivatives, and L'Hopital's rule to do the limit says you have to have the derivative. So a little bit of circular stuff there. So I always just teach it at the end, and then that leads us back into limits to review for the AP exam and the final exam. So, all right, so what is L'Hopital's rule? So what his rule says is, if you remember, when we did limits, there was 4 different options that we got. We either got 0 divided by 0, which meant that we had work to do by doing factoring or multiplying by the conjugate or something like that, or it was 0 divided by a number. We're going to go over all this on Friday. So if it was 0 divided by a number, you got the number. If it was a number divided by 0, then it does not exist, or you get a number divided by a number, and that's just the number. So instead of having work to do with 0 divided by 0, there is a shortcut for some of the problems called L'Hopital's rule. So I'm going to scroll down here. This is on page 459, 460 in your book. This is taken right out of your book. And what his whole rule says is that if you get 0 divided by 0 or an indeterminate form, then you can simply take the derivative of the top and the derivative of the bottom and then just plug that number into that. Now I will, here's a nice little picture of him right here on the left, and then you can see other forms of indeterminate form. So it's infinity divided by infinity, infinity times 0, infinity minus infinity, 1 to the infinity, 0 to the 0, infinity to the power of 0. Now in Calc 1 here, we are only going to be dealing with 0 divided by 0 in your homework for tonight. So you have 7 problems. All right, so let's get to those problems. If you want to pause this and go back and read all this stuff, that is fantastic. Go ahead and do that. But I'm going to move on to tonight's homework. All right, so you're going to need a graphing calculator for these. Again, if you still don't have one, you can go to Texas Instruments. It's on the Google page and download one. So you're going to need that to figure out whether it's A, B, C, or D, which graph it is. So go ahead and do that. You can pause it and do that now if you want. I'm just going to keep going so we can get this all done in the 15 minutes limit that I have. All right, so it says, examine the limit graphically. That's what you're going to do when you graph it. And it says, as x approaches 8. So let's go back to, what are limits again? So as x approaches 8. So here, as you see, x approaches 8. From the left side, it's approaching infinity, negative infinity. From the right side, it's approaching positive infinity for graph A. For graph B, it looks like it's approaching 0 from the right and from the left right there. Remember, the answer to a limit is a y value. Over here, it looks like it's approaching 2. And over here, it looks like it's approaching 0. So without even doing the problem yet, my guess is on B and D. Because if you look at B and D, they're both approaching 0. In a multiple choice test, if 2 of them are approaching the same or close and the others are not even close to it, if you have no idea, I would either pick B or D. All right, anyway, and you can graph that on your graphing calculator and see if it's A, B, C, or D. All right, so how do we apply L'Hopital's rule? So the first thing we need to do is we actually need to plug in 8 and see if we get 0 divided by 0. Because if we just get a number, we don't have to do any of this. All right, so let's go ahead and plug in 8. So we get 2 times 8 minus 16 on the top, and 7 times 8 squared minus 448 on the bottom. On the top, 2 times 8 is 16, minus 16 is 0. On the bottom, 8 squared is 64, times 7 is 448, and 448 minus 448 is 0. So we can use L'Hopital's rule on this because we are getting an indeterminate form, which is 0 divided by 0. Okay, great. All right, so how do we do that? So what we're going to do is we're going to move down here, and I'm going to say the limit as x approaches 8 is going to be the derivative of the top divided by the derivative of the bottom. So what is the derivative of 2x minus 16? That is simply just 2. And what is the derivative of 7x squared minus 448? That is simply 14x. All right, so in order to find the limit, as you may or may not remember, this is a good lead into Friday, you simply just plug 8 in. I picked purple, I didn't go to purple. So you simply just plug 8 in. So we get 2 divided by 14 times 8. All right, so 1 over 8 reduces down to 1/4. So that's 1 over 14 times 4. So that's 1 over 56. And keep in mind, this is a y value. Limits always approach a y value. And look at that, 1 over 56 is going to be just about 0. So it's either going to be B or D. Because A is approaching infinity and negative infinity at 8, okay, because we're looking at 8. That certainly can't be it. And C is approaching 2, so it can't be that. So it's either B or D. And I'm not going to take the time to graph it, so we can get all of this done in my 15-minute time limit. All right, so next is this equation right here. Okay, so what do we have here? We have the limit as x approaches 0 of negative 3 times the sine of 5x divided by x. All right, so we're going to plug in 0 and see what happens. So I need a pen. Okay, when I plug in 0, I get negative 3 times the sine, sorry, this does not write well, of 5 times 0 divided by 0. Okay, so we're good with the bottom being 0. What is the top? Well, the sine of 0 is 0. If you remember your sine curve looks like this. So the sine of 0 is 0. So that's negative 3 times 0 divided by 0. So we get 0 divided by 0. So we're good. We can use L'Hopital's rule. Now, all of these I picked, we're going to use L'Hopital's rule. All right. Okay, so now we're going to take the limit as x approaches 0 of the derivative of the top. So what is the derivative of sine? The derivative of sine is cosine. So we're going to end up with negative 3 times the cosine of 5x. Now we took the derivative of sine and got cosine. We never took the derivative of 5x. This is a good review of derivatives. So then you got to multiply by 5 divided by the derivative of x, which is simply 1. Okay, so now we can plug the 0 in. So we're going to get negative 3 times the cosine of 5 times 0. The whole thing times 5 divided by 1. All right, so 5 times 0 is 0. So what is the cosine of 0? The cosine curve, if you don't remember the cosine curve, I don't even know where I'm going to draw this. Okay, so the cosine curve looks like this. It starts here, goes down and back up. So the cosine of 0 is 1. So this is going to be negative 3 times 1 times 5 divided by 1. So that is going to be equal to a negative 15. And negative 15 is going to be the limit as you approach 0. So when you look at these graphs, it can't be A because that's not approaching negative 15. B is approaching 2 different things, so that can't be it. C is approaching negative 15. And D is not approaching negative 15. So I don't even have to graph this one. I can tell by what I got for an answer that's going to approach negative 15. Okay, all right. So you simply just see if you get 0 divided by 0. If you do get 0 divided by 0, then you just take the derivative of the top divided by the derivative of the bottom. All right, so let's go to the next one. Okay, this one's going to be a little bit tougher because that's square root. But think what we had to do before. We had to multiply by a conjugate. I don't know if you guys remember doing that. So thank goodness we have L'Hopital's rule. So this is actually making your life easier, believe it or not. All right, so, okay, we're good on time, 5 minutes, 5.5. Okay, so for this one, what we're going to do for this one is we're going to plug in our 2 And when you plug in the 2, we get the square root of 2 plus 2 minus 2 divided by 2 minus 2. And 2 plus 2 is 4. Square root of 4 is 2. 2 minus 2 is 0 divided by 0. So once again, we can use L'Hopital's rule, but we need to figure out, okay, what is the derivative of the top, the derivative of the bottom? So to find the derivative of the top, if you remember, for derivatives, we don't use radicals. So I'm going to rewrite the top as 2 plus x to the power of 1/2 minus 2 divided by x minus 2. So that is what I'm actually taking the derivative of. So I am going to, that's just like a little side note. So I'm going to move down here and I'm going to do the limit as x approaches 2 of the derivative of the top. So what is the derivative of the top? The derivative of the top is 1/2 times 2 plus x to the power of negative 1/2 times the derivative of the inside. The derivative of the inside is just 1, and the derivative of minus 2 is 0, divided by the derivative of x minus 2 is simply just 1. All right, great. Okay, so now I'm actually going to, it says I could simplify this, or I could just plug the 2 in. It doesn't really matter. It's divided by 1, so we can just kind of get rid of that. So when I plug the 2 in, I get 1 divided by 2. Okay, this is going to move to the bottom, this part here. Why does that move to the bottom? Because it's a negative 1/2. So that is going to be the square root of 2 plus 2, and then times 1, which we don't even need. Okay, so 1/2. You guys aren't here to help me in case I screw up. So if I screw this up, I apologize. You'll have to correct it with each other and on your own. Just move that to the bottom. 2 plus 2 is 4. All right, so we're going to end up with 1 divided by 2 times 4. Square root of 4 is 2. 2 times 2. So I'm getting 1 over 4. And that is what I'm getting for an answer. All right. Okay, moving on. Last one. Good job, people. Okay. Hang in there. All right. The last one. Apply the stronger form of L'Hopital's rule. What in the world does that mean, the stronger? What that means is that if you get 0 divided by 0, you can use L'Hopital's rule. Then if and only if you get 0 divided by 0 again, you can use L'Hopital's rule again. If you get something other than 0 divided by 0 or an indeterminate form, you cannot continue to use L'Hopital's rule. All right, so pi over 2, if you remember, pi over 2 is equal to 90 degrees. All right, so for lack of time, I'm just going to tell you that when you plug this in, you get 0 divided by 0. You do. Okay, so now I'm going to go ahead and take the derivative. So when I take the derivative, so I'm going to get the limit as x approaches, or theta approaches, I'm going to change it to 90 degrees. So on the top, the derivative sign is cosine. So it's negative 7 times the cosine of theta. On the bottom, I'm going to get derivative cosine is negative sine. So I'm going to get negative 5 times the sine of 2 theta, and then times derivative of 2 theta, which is 2. All right, okay. Now, if you remember, you have your sine and your cosine curve. Just rewriting that theta. All right, so your sine curve looks like that, and your cosine curve looks like that. Okay, so the cosine of 90 degrees, here's your cosine of 90 degrees is 0. So I'm going to get 0 divided by, now the sine of 2 theta is 180 degrees. So here is 180 degrees, and here is 90 degrees. So imagine that I get 0 divided by 0. So when you get 0 divided by 0, you simply take the derivative again. So we get the limit as theta approaches 90 degrees, and I take the derivative again. The derivative cosine is a negative sign, so that's 7 times the sine of theta. This is negative 10, so divided by derivative sign is a cosine, so negative 10 times the cosine of 2 theta times 2. So now I plug in 90 degrees and I will actually get an answer. And my time is going to run